Yo, what's up, guys? So today I want to show you guys my attempt at making an ALU, or arithmetic logical unit. Um, so as you can see, it's just a lot of operations, and they all go to one output. I haven't linked everything up yet, as you can see here. So they're all different inputs, but I'll eventually link these up. Here, this is my adder slash subtractor. I can do something like maybe we can add 5 and 3, which should be 1, 0, 0 is our output. Now all I need to do is I just need to unlock the addition output and or input, and then also unlock the addition output. And as you can see here, let me just go over here, we get 8. Now I could do the same thing with subtraction. So if I lock these, maybe I want to do, so this one's going to be the larger number, so I could just kind of reverse it here. So I could have 5 minus 3, and that should give us a 2, so 1, 0. So I unlock the subtraction input and subtraction output, and we have 1, 0. So that's my addition slash subtraction uh, component. Here, it's just a very simple um, XOR gates, but if you notice there's something different about these, they're all hooked up. So again, this is what an XOR gate would look like in Minecraft. How an XOR gate works is it will only output a 1 if one of the lamps are on. So notice I could do this, right, and it outputs a 1, or I could do this and it outputs a 1, but if I have 0, 0 or 1, 1, it outputs a 0. Now, I do actually have a separate XOR gate right here where it will just XOR two numbers as like an operation, but this is I will use for my if statement. So this will check if two numbers are equal. And so I realized that because when there's two zeros or two ones, like when the numbers are the same, it outputs a 0, and when they're different, it outputs a 1. So I just hooked up all the outputs together, and I basically just said if there's a 1, or if even if a single 1 is being outputted, then it will say that they're not equal. And over here, this is just kind of I labeled it too for myself so I don't get confused. This is what I unlock for the equals, and this is what I unlock for the not equals. So that way I can choose if I want to check if two numbers are equal or unequal. And my second logical part over here is this is a greater than or less than. So how this works is I'm going to work on a better design for this because this is very slow. This relies on a torch tower, which I do not like at all. So I will be working on a better way to make that. But how this really works is it's built around the concept that whichever number has the highest ones digit, so again, this is from top to bottom, highest at the top, lowest at the bottom, whichever one has the highest digit with a 1, it means it's going to be larger by default. So here I just used, again, XOR gates. And so again, like if these two are here, it's like, okay, well, these are the same, so we can't tell which one's higher yet, so I'll put a 0. But when we when we do, okay, this, right, maybe we'll have some, I don't know, like this, it knows that this is a bit bigger. So what happens here is, notice these all three output a 1, but only one of them is actually outputting a 1. Notice, so again, see, these are all powered, but these comparators are not going off. And that's because how this works is it will lock, once it finds a 1, it will lock every repeater, or sorry, comparator below it. So these are all on, so no other difference below it can change it. So, even if we have something like this, and we see that it has way more ones than this number, it knows that this number is the highest digit, or will determine which one's the highest, because it's the largest digit. And then what will happen is it will basically unlock, so these are all carried around, and depending on where the actual output is, it will unlock the comparator that's bringing this, like it will basically unlock the output of whatever digit is at that place value. And so then as you see, it carries all the way down, and it will determine if it's larger or smaller. So this is the right one's going to be what I'm comparing it to. So I could say maybe we could check if 5 is greater than 3. If 5 is greater than 3, and again, this is going to return kind of like a Boolean, like a true or false value, so 0 or 1. So let's see, if I want to check, sorry, I'm on equal. If I want to check greater than, I will unlock this, and notice it's a 1, meaning that it's true. But then I could also unlock this less than, and it's like, okay, well, 3 is less than 5, because we said 5 has the highest digit, so we know that 5 is not less than 3. And so it's really simple. It's really just if there's a 1 being outputted from this side, then if there's a 1 being outputted from this side, it means that it is greater than, and if there's not a 1, it means less than. So I kind of just built it around that logic there. Um, and then most of these are just very simple logical gates. So we have, again, just an XOR gate, just plain XOR gate. Here, this is going to be an OR gate. So again, literally any lamp that's on will give out a 1. We have an AND gate here, so it will only output a 1 if both are on. And right now it's locked here, so I can't. So again, if I were to unlock that, it would go through. But I'm just keeping them locked so that it's easier, so I can pick which operation I want to do. And then this is kind of looks a little ugly, but it's a bit shift. So this is just shifting it down 1. This shifts it up 1. Obviously, there's nothing above it, so I guess I kind of have to do this one. But it's just 2-bit shift operation. So that one will only take 1 number. And shift it up or down depending on whatever I want. So that's my attempt at an ALU. And this can be my one output. I will figure out a way to, I mean, first of all, I can connect these outputs up the same way I kind of connected those. It was very ugly, but I managed to do it. Kind of same thing here. And what I will need to work on, I don't know if I'll do it next video. I'm still deciding what part I want to make, but I need to make a CU or control unit eventually so that it can determine what function the computer is supposed to do based on the instructions. So I will keep working on this, connecting everything up, making more parts. But for now, that's about it. Peace.